Hello everybody and thanks for tuning in. This is going to be part 3 of the DIY CNC machine build here. And in part 1 we went over changing out the lead screws over to high precision ball screws. And in part 2 we mounted the power supplies, the motor driver and the control board into the control box. So today I'm going to wire up all the internal connections in the control box, as well as wire up the emergency stop switch to run another cable out here that's going to go to the control box so that it knows when the emergency stops button's pressed. And so hopefully we'll be getting these motors connected, and if everything works out, I'm going to try a computer I've already got the software loaded on to see if it'll open this or work this thing. Otherwise, I've got a brand new laptop, and the motor driver that I went with, it actually came with a licensed file for Mach 3. So everything that's going to be going on this machine, it's going to work through the Mach 3 software. It's a software that I have used I've used it in the past. I wouldn't say I'm a pro at it, but I know the basics as far as getting the programs written to run the G code and spline the machine, or spline the parts. So let's see how this goes. First up, let's get over the control box. Alright, so going over the instructions that came with the breakout board here, it actually wants a 12 to 24 volt power supply input for all the inputs and outputs that the board runs. And since that includes the emergency stop switch, I went ahead and I had one of these lying around, a little 12 volt power supply. It just mounts right onto the rail. And then I picked up some terminal blocks for the AC connections here, and then these are all going to be for the 5 volt connections that are going to be running from these outputs here to each of the motor drivers. So I've got this rail kind of pre-put together. I kind of just gave a guess. I'm sure I've got too many of the terminal blocks on this side, but I'd rather have too many than too few and just end up running out of railing here. So I'm going to go ahead and get this mounted up, and I'm going to mount it so that I can access the wires kind of in between the power supplies here, so, and still give me plenty of room to be able to make my two connections here. So I'm really liking this spot, and one hole's already drilled and tapped just on this factory back plate here. So I'll leave that, and then I need another hole for up here. And again, I'm using the 632 drill tap here. So drill and tap all in one here. I apologize for the noise, but I need to turn that air conditioner on. Alright, so now that this thing's mounted, go ahead and put my end blocks back on. Each of these pull at 220 volts, 6 amps. Usually I'd recommend going with a smaller wire. I mean, I'd recommend 16, 14 gauge would even be overboard. I mean, these really aren't pulling that much. What I have is probably way overkill. It's rated for 30 amps, but I'm going to use it because it's what I got. that's it for the AC side. So I'll have my input coming in and it'll feed these center lugs, which these jumpers connect them over to the other side. So I'll basically have line 1 and line 2 coming in, and then they feed each of the 4 power supplies here. All my grounds will end up getting daisy chained together, and then they go onto a lug that mounts there. So once this drops in, then I'll be able to run the grounds to everything. With that being done, next I'm going to run my 12 volts over to that, and then I have to run the 48 volts to each of those, and 5 volts is going to get run through here coming off of the board, and then it's got a bunch of connections to make on the motor drivers there. So let's get to it. Alright, so first up I'm going to run the 12 volt DC. And it's just some 18 gauge wire. Again, we're not pushing much through here, it's only a 3.3 amp power supply. So that gets connected all the way at the end here to over here. Volts hooked up, so that'll give us power for the emergency stop switch. Now we need to run DC power to these, and again, it'd be nice to run something with a little bit of conductor power. Some 16 gauge would be nice, so I'm gonna grab some more of that. Well, what I've got is 12 gauge. So I'm going to use this for the DC power. So I guess if any of this stuff ever fails, I can put a way bigger unit in there and it'll be pre-wired to handle it. So I guess consider that a bright side. So DC comes in through here. Now I just want to show you these stepper motor drivers. It's kind of a joke here. So in the instructions, I guess I shouldn't yell at you here. Input voltage. In parentheses here is AC. So 36 to 110. Out of parentheses 18. 70, it'll take 80 in DC. Or it kind of contradicts itself a few times here. I know I've seen it. But meanwhile, because if that was the case, these motor drivers would be able to plug into AC power, right? Just 110 volt AC. But we go over here to the driver itself. It says AC right here. But AC, it only goes up to 80 volt, or DC, it goes up to 110 volt. But we go to the instructions here. AC 110 volt. AC 80 volt. Instructions and the product itself contradict each other. So that's why I'm using DC power supplies, because the information coming with these drivers is crap. And when it comes to just even wiring this thing up for power, it doesn't even give you a polarity to go by for your DC power. And that's not good. Okay. So yeah, there it is, right there. 18 to 80 volt AC or 36 DC, but only up to 80 volt DC if you've got a different one. We've got the Model T, not the Model I. And the polarity is not illustrated anywhere in the book. The few pages you get, I think there's one more in there. Yeah. Alright, so here we've got a bunch of connections that are just going to be going to 5 volt. And what they are is it's going to be the positive side for pulse and direction, and the positive and the negative for the axis enable. So each of those 4 wires are going to come up to these terminal blocks. Most of these terminal blocks are going to be linked together for 5 volts. Just every 3 of those are 5 volt outputs. And then the negative for the axis enable will get daisy chained to the bottom set of these terminal blocks. So to connect all the 5 volt stuff up, I'm going to use this wire here. It's 18 gauge, it's well insulated, and it's stranded wire, copper wire in there. So it's going to actually do a really good job carrying that 5 volt signal across. And let's get to hooking that up. So the only thing I really need to pay attention to of these is which one I'm hooking up to the axis enable negative line. So I'm going to start with that one. We'll use black and just get all of those hooked up. So enables that one. And then I guess we'll use red for the axis enable hot. And then green and white we'll use for A plus and B plus. Now the A minus and B minus lines are going to go directly back to the control board, because that, when it grounds out, it's how the signal gets through to step and pick the direction and send the stepper motors going. So bring that down here. Alright, so the black wire we're going to connect to the third one down here. And these ones will all get connected to 5 volt, which will be the top of this terminal block. So there's the first of those wires going in, and then they're just going to go up and over, and there's that. So I'm going to repeat that for the other 2 drivers, and then we'll make progress some more. Alright, so I've got all 3 of these hooked up, and again, this is enable over here, and then I've got pulse positive and direction positive hooked up over here on each of the 3, and then they come into this terminal block, and I've got these 6 jumpered together, so all of those are connected. One side comes in on this, and then I've got my 5 volt and So these red wires right here are the 5-volt, and then the black wire is the axis enable. So the two 5-volts come in on each side of the jumpered set, and then the black with the red stripe here, that is the axis enable, which is the negative side, comes in and feeds these over here. And I still need to put a jumper there. I just don't know how many in between I'm going to finish off using, so we'll see. So that's where I'm at. I've got the 12-volt run in. So now I got to connect my direction. Let's see down here. We've got a X pulse, X direction, Y pulse, Y direction. So we'll be using those 4. And then we go over here to A, and we got A pulse, A direction. We'll be sending each of those to the respective motor drivers, and then we still got to hook up power to the motor drivers from the power supplies, and then we've got to hook up the 4 wires that go out through the box to the motors. So we're going to work on those connections after we've got the power supply hooked up and the rest of the internal connections done. Then I'll mount that plate back into the box, and we'll see where all the external connections are going to go. Alright, so before I get carried on too far here, before everything gets too crazy with wiring, these wires, the blue and the white one I had over here, and it's because I'm doing all the work from this side, I couldn't see the labels correctly on that side, but I moved them over. They're actually supposed to be the 5-volt positive for pulse and direction. So I moved the white and greens over on all 3, and then for the negative connections, I ran these 18 gauge wires around into the pulse and direction pins for X, Y, and A. So I've got that wiring done. So for the internal wiring left to do, I got to go dig up some more wire. I got to connect our 48 volts to each of these motor drivers, and then the other 4 terminal slots are going to be the outputs that go through the box to the actual stepper motors. Again, we'll have the one output going out the box for the emergency stop button, and then I'll have another connector that I'm going to be using just to pass through the box, because I'm using these bayonet. Let's see if I can get this apart. Not one-handed, but I'm using these bayonet style connectors, 4-pin, and on this VGA style plug here, it's only got 4 wires in there, so I'm going to desolder those, and then basically have that plug into the board and have the 4 wires go straight up to another pass-through. So, and then I've got my USB pass-through down here on the ground, and that's going to go in the box right there. So as soon as I dig up the wire and get those power supplies hooked up to the motor drivers, we're going to get that plate mounted back in the box and start working on the external connections. Alright, so back here over at the mill, I've got this panel kind of held back up in place, and basically there's a knockout hole already punched out right here, and I need to run a wire from there back underneath everything to the back side of this emergency stop switch. And so if I pop this back off right here, you'll see that the emergency stop switch right here, it only has the one side hooked up. So I've got another switch to bolt down to the other side, and that'll be for the 12 volt loop coming through. So I'm gonna go ahead and cut my wire to length for there and take it over to the bench and start soldering up the connections. get that zip tied up. Alright, so you can see the second switch on the back bearing. Go ahead and put this plate back in. Alright, I'm going to leave the side panel off because I've still got to work out everything here because it looks like it's potentially set up to run 120 volt. I need to make sure everything's wired up in there and in the motor plate for 220 volt. So just take a look at what I did there. This is a twist lock connector, 4 pins in there, and that basically one pin's going to supply 12 volts. The other is going to go to input 1, that's for the emergency stop. So when you hit that button, input 1 gets that 12 volt signal and knows to shut everything down. I still have 2 pins there, so potential options would be spindle on and spindle off feature with just running that connector. So those aren't needed for what this project is for. He wasn't wanting this computer to turn this spindle on and off. He just figured he'd do it with the button. So, but that's where you'd make those connections if that was going to happen. So that about wraps up this episode here. In the next one, I'll be doing the rest of the breakouts for the control box and then getting started on booting the software up on the laptop, make sure this thing's moving correctly. And then in the final video, I'll be doing the indexing head and make sure that with the new one, I'm not just building it from scratch at home, and maybe I buy the right size fasteners. And this was a 3D printed piece that I had made. It's basically just a shim so that the shafts line up, and then you got a little coupler inside there. So I'll be changing it, but it'll still be pretty much the same deal with the stepper motor running it. So that's going to be the last episode, and we'll have it cut its first splines. Alright, thanks for watching. Hope you liked, and please subscribe and turn on notifications. You'll get the updates when the next videos are done. Thank you.